The CPU thinks in silence, but behind that silence a hidden world moves, a world of switches firing, opening, and closing billions of times every second. In this episode, you step deeper into the heart of computation, into the place where electricity learns to choose, where physics becomes logic, and where the smallest switches create the biggest ideas. Welcome to the world of transistors and logic. Before the transistor, machines were giants, vacuum tubes glowing, buzzing, breaking, and heating rooms like tiny suns. They worked, but only just. Then came a breakthrough, a device smaller, cooler, faster, and more reliable. A switch made from crystal, not glass. The transistor. A moment that shrank machines from rooms to pockets and made the CPU possible. Simple in concept, a gate, a barrier, a channel, but world-changing in impact. It became the foundation of every calculation, every instruction, every digital thought. The spark that ignited the digital age. Shrink down to the nanometer world, where a transistor waits, carved into silicon. A source, a drain, a channel, and a gate. The gate is everything. Apply voltage, and the channel opens, electrons flow, the switch turns on. Remove voltage and the channel closes, electrons stop, the switch turns off. 1 or 0. This is the language of the CPU. Billions of switches flicking every moment, creating patterns, creating logic, creating meaning. A transistor is not just a switch, it is a storyteller. It tells the CPU what is true, what is false, and what comes next, speaking at speeds beyond imagination. One transistor is a switch, but together they become something more, logic. NAND, NOR, and OR, XOR, the building blocks of digital thought. Each gate is a tiny machine taking inputs and producing an output, true or false, 1 or 0. From NAND alone, you can build anything. Every circuit, every instruction, every algorithm rises from these simple gates. Complexity from simplicity. A universe built from ones and zeros. Logic gates do not stand alone. They connect, combine, and form circuits. Adders, comparators, multipliers, registers, decoders. Each one a structure, a machine, a purpose. An adder creates a sum. A comparator decides which value is greater. A decoder reads a pattern and opens a single path. These circuits are the organs of the CPU, each one working in perfect rhythm. Together, they form the architecture of thought. Behind every gate, every circuit, and every decision lies a simple idea, truth. Boolean logic, the mathematics of true and false. A system where everything can be expressed as ones and zeros. This logic is the CPU's language, is how the machine understands a world. If this, then that. If not this, do that. Every program, every algorithm, every instruction is built on Boolean logic, is the grammar of computation. In the physical world, there are no ones and zeros, only voltage. High or low. A threshold defines the line. Above it, the CPU sees a 1. Below it, a 0. This is how meaning emerges from physics. Electricity becomes logic. Logic becomes computation. Computation becomes experience. Your apps, your games, your videos, your world, all built from voltage crossing thresholds. A single transistor is tiny, but a CPU holds billions, each one switching in perfect coordination. This is not chaos, this is choreography. A dance of electrons, logic, and timing. The more transistors, the more logic, the more power, the more possibility. CPUs grow stronger every generation not through magic, but through scale. Billions working as one. You have seen the switch that changed the world. You have seen how logic emerges from physics, how truth is carved into silicon, and how billions of tiny gates create the foundation of every digital moment. In the next episode, you will follow a single instruction, from memory to execution, from idea to action. The journey continues until the next instruction. Thanks for watching, and I'll see you in the next chapter of this digital adventure.